Welcome to day 1 of the STL Mastery course. Today marks the beginning of our deep dive into one of the most powerful features of modern C++, the Standard Template Library. Our session is titled Introduction to STL, What, Why, and How. We will explore what STL actually is, why it's a game changer for C++ developers, and how we can start using it today. By the end of this module, we will be writing our first STL based program and we will have our development environment fully set up for C++17 or C++20. Let's begin with the objectives of today's session. First, we will understand what STL is and why it is a fundamental part of C++ programming. Then we will explore its key components. This will include containers, iterators, algorithms, and more. Next, we will go over setting up our development environment for STL support. Whether you are using an IDE like code blocks or a lightweight editor like VS Code. Finally, we will apply what we have learned by writing a simple program using STL containers and algorithms. So what exactly is the STL? STL stands for the Standard Template Library, and as the name suggests, it's a template-based library that's part of the standard C++ library. STL provides a rich set of classes and functions that make handling data structures and algorithms easy, efficient, and consistent. Rather than reinventing the wheel every time, STL lets us use well-tested and optimized implementations of containers like vectors and maps and algorithms like sort or find. It's generic, which means it works with any data type thanks to templates. Now that we know what STL is, let's talk about why it's so useful. First of all, productivity. STL lets us write less code without sacrificing performance. Need a sorting algorithm, it's already built in. Want a dynamic array, just use vector. Second, STL is highly optimized. Most STL code is as fast or sometimes even faster than code you would write manually. It's also reusable and reliable thanks to years of testing and standardization across compilers. And finally, STL is a standard, meaning every modern C++ compiler supports it. That makes our code portable, consistent, and easy to share. STL is composed of 5 main components. First, containers like vector, map, set, PQ, and others. These are used to store data in different structures. Second is the iterators, which are like pointers that help us navigate through containers. Third is the algorithms. These include things like sort, find, count, and accumulate. They work seamlessly with containers and iterators. And fourth is function objects or functors, which allows us to create custom behavior when working with algorithms. And finally, STL includes several utility tools like pair, tuple, bitset, and newer additions like optional variant and any in C++17. Let's take a look at how STL is used in the real world. In competitive programming, STL is indispensable. Fast implementations of set, map, and heaps make solving problems efficient. In system design, STL helps with implementing caches, indexing systems, task queues, and more, all with minimal code. And in real world software development, STL is everywhere, from text editors to financial software, anywhere where structured data is being handled. Let's now set up our development environment. If you are using a C++ IDE like docs or dev C++, go into the settings and look for compiler flags or compiler options. You will want to enable support for the modern C++ standard, either C++17 or C++20, by adding the flag std equals to C++17 or std equals to C++20. This will allow you to use all modern STL features we will cover in this course. Prefer VS Code? No problem. Make sure you install the C++ and Code Runner extensions from the extensions marketplace. To compile your program, use the integrated terminal. You will run the command g++ std assign std equals to C++17 main.cpp -o main followed by dot and / main to execute it. VS Code is lightweight and fast, and with the right setup, it's perfect for STL development. Don't want to install anything? That's perfectly fine. There are several powerful online compilers you can use. Godbolt.org is fantastic if you want to see how your code, how your C++ code compiles into assembly. Great for learning. OnlineGDB gives us a full debugger inside the browser, and Replit is excellent for collaborative coding and running programs online. Any of these platforms will work just fine for today's hands-on. Here's a basic STL program in C++. We start by including the necessary headers, vector for our container, and algorithm for sorting. We declare a vector of integers, initialize it with some values, and then sort the vector in ascending order. Finally, we print the sorted list using a range-based for loop. This is STL at its simplest, containers and algorithms working together. Let's walk through what this code is doing. Hash include vector brings in a vector container class. Sort nums.begin, nums.end sorts the vector using iterators, a key STL concept. We use a vector int to store our data and a range-based for loop to print each element. This is both readable and efficient. You will use this style often throughout the course. Now it's your turn. Write a short program where the user inputs 5 integers. Store those integers in a vector, then sort the vector and print the numbers, but in reverse order. To do this, use sort followed by the reverse function. This small exercise helps you get comfortable with STL syntax and with compiling and running C++ code in your setup. Before we wrap up, here are some quick tips. Always prefer STL containers over raw arrays. They are safer and come with useful methods. Only include the headers you actually need. This keeps compile times low and code clean. And use the while flag when compiling. It enables all compiler warnings, helping you catch bugs early in the development process. To go deeper into STL, here are some excellent resources. cppreference.com is your go-to reference for everything in the C++ standard library. hackingcpp.com offers visual guides and cheat sheets that are great for quick revision. And godbolt.org, the compiler explorer, helps you understand how your C++ code translates under the hood. It's a powerful tool for understanding, optimizing, and performance. To summarize today's session, we introduced the STL and its importance in modern C++ development. We learned about the 5 core components of STL and how they work together. We covered multiple ways to set up your development environment and wrote our first STL-based program. Tomorrow we will build on this foundation by diving into templates and iterators, 2 crucial building blocks for mastering STL.